outcomes of tossing a pair of distinguishable coins, there are 4 total outcomes. So these are the ones here: heads, 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 tails, tails, heads, tails, tails. Indistinguishable coins. Ooh, actually, maybe I don't have this quite right. Let me check that. Not sure what it means by indistinguishable coins. Okay. So that would be the case where you can't tell the difference between tails, heads, and heads, tails. So I'm going to guess it's this last one here. That's correct. Okay, so number 3, it says the set of outcomes of tossing 3 distinguishable coins. So that's
Oh wait,
it's
I'm looking at your Snipton page.
okay. So let me new share. Okay, we'll just run through this. Okay. Do you see
There we
question
go.
3 now?
Mm-hmm.
Okay, so there's 3 coins, and that means there's 8 possible outcomes. That there's 2 for each position of the coin. 2 times 2 times 2 gets you to 8. That's why this one's here. The problem is that like it doesn't, with indistinguishable coins, it doesn't differentiate between, like, see how this second one has 1 tails and this one right here has 1 tails. It wouldn't be able to distinguish between the 2 of those. So
Okay.
there's fewer
Right.
options. 1, 2, 3, 4, 5, 6, 7. So it's not that one. Tails. I'm not seeing the one where it's got 2 tails. Oh, there it is. There it is. Okay. So this has 2 heads and 1 tail, 1 head and 2 tails, and then 3 tails. I mean, I don't think you'll get too many of these on a test.
Mm-hmm.
Okay. The set of all outcomes of rolling 2 indistinguishable dice such that the numbers add to 10. So you're looking for the numbers that add to 10. So 4 and 6, 5 and 5, they add to 10. Those are the only possible ones there. All right, draw a Venn diagram that illustrates the relationship among the given sets. So C is pomegranates. Okay. So this one here has pomegranates for C, and A has Dell, Gateway, Dell, pomegranate, compact. Gateway, Dell, pomegranate. Okay, so this one on the top right here. So C contains pomegranate. You can see that. And then A has Gateway, Dell, pomegranate, and then compact. But B also has pomegranate in it. You can see that still works out for that one. And that's all the ones that are there. All right, so find the given set. B union the empty set or the null set. That means there's nothing else with it. So union means or. So this is B or the empty set. That's going to include all the elements here. So it's the one that has all of those elements. June, Janet, Jill, Justin, Jeffrey, and Jello. All right. So this one says A union B union C. So the first thing you do is find B union C. So B union C means it's B or C. So it's ones that come in B or C, which is John, Jelly, Jared, and then all of these over here on the right. And Jelly is not twice. So it's just John, Jelly, Jared. I don't see that. Oh, there it is. Okay. And then the A means it's also these. So any ones that were missed in this list over here, B or C, is picked up here. So it's gonna be like it's basically all the names: July, John, James, Jared, Jeffrey, Jelly, Irina, Arena, Arena. Well, yeah, that would be really tough to do. Okay, number 8. So this upside down U is intersection. It means it has to be in both. So it has to appear in both B and C. So only names that appear in both. So notice Jelly appears in both, but nothing else does. So it's just Jelly. Okay. Number 9 here. Let A equal heads and tails be the set of outcomes when a coin is tossed, and B be the set of outcomes when a die is rolled. Okay. The set of outcomes when a coin is tossed twice. So I think your book is introducing this cross notation, but I can't believe they're doing that in this class. Okay, that's weird. So this cross notation is when you have to kind of overlap this own set with itself. So the elements of that set, we've already seen that here. That's where it's, you got heads, 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 tails, tails, heads, tails, tails. Just flipping a coin twice. Okay. Let S be the set of outcomes when 2 distinguishable dice are rolled. E is the subset in which at least one die shows an even number, and F be the, okay, so we actually don't care about F, we only care about E. E is the outcomes when there's at least one die shown as an even number. E complement, or E prime, is where there's not at least one die that shows an even number. So that would be no even numbers. So no even numbers looks like this one here. Yep. Okay. The clients who owe her money and have done at least $2,000 worth of business. So owe her money, and means it's an intersection. So it's either the upside down one, this upside down one here, or this upside down one here. So owe her money. So who owes her money? So there's A is the ones that owe her money. That's A. And have done at least $2,000 worth of work. That's B. B are the ones that have done at least $2,000 worth of work. That's why it's A intersect B. Now the clients in the subset, that means the ones that are in both. So what's in both A and B? Aces appears in both. Crafts appears in both, and that's it. So it looks like it's aces and crafts. Okay, so this is kind of the same problem. I've done at least $10,000 worth of business with her, and so it's an and again, and have been employed with her in the last year. So that's B intersect C, it looks like. And it's the ones that appears in both. So Acme appears in both. Crafts appears in both. And Dion appears in both. Looks like that gets it done there. Okay, you are searching online for techno music that is neither European nor Dutch. Okay, so it's not European and it's not Dutch. So you want techno music, but you don't want it to be European or Dutch. So European or Dutch is here. Okay, and then this complement here means not.
Mm-hmm.
Okay, and then but if you want it to be techno music, that's kind of an and. That's why it's a upside down thing there. All right, 14. We have to find A intersect B intersect C. So B intersect C, we're looking at what's in both of these lists. Has to be in both. Is John in both? Nope. But Jelly is. Jelly is in both. Now, is Jelly in A? It is.
Yes.
So that's the only one that's in all three. This actually means all three. A intersect B intersect C means it has to be in all three. Okay, 15 here. The first thing you have to do is figure out which ones are in A and B, which ones appear in both A and B. So John appears in both. John is in both. And then Jello is in both. And Justin is in both. Okay, so A intersect B is really like everything in B because John, Jello, and Justin appear in both. So it's all of those or C. So this union means or. That means if you see a new name, you just add it to the list. So it's John, Justin, Jello. Then there's Irina, and then Jello appears again. So it doesn't show up on the list. Okay, so A cross C, A cross C here. So what this means is you look at A and you look at C and you pair small up with each of these. So like they're small pentagonal, small square, medium pentagonal, medium square, large pentagonal, large square. And I think it's that first one there. You can cross something with itself. We saw that before. It's weird, doesn't make much sense, but that's what it means here. Okay, so 17 here. 17, we're looking for A union B, but then the complement of that. So A union B is when you fill in all of this, including the middle point. So the complement of that is everything on the outside of the two circles and nothing inside. Okay, good. We're on the last one here. Okay, the clients who do not owe her money, or have employed her in the last year. So do not owe her money, or, so the or is the union operator. Do not owe her money. So those that owe her money are A, do not owe her money are A prime. And then employed in the last year is C, so A prime or C. So this one's a little bit harder to find. It's all the people in C, I think. Actually, let me check that. Okay, so yeah, that's right. So it's all the people in C, and then the people that are not in A. So you might be, well, how do I figure out what's not in A? Well, you go back to the S. S is everyone. So it's the names that are not in A. So like so Baker's is not in A. So you'd add that to the list down here. You can see how that one has Baker's in it. Coors is in the list. Dion's not in the list, but it is down here. Energy is in the list. You don't do anything. Floyd's not in A, and it's not in C, so you would add that to the list. That's why Floyd is in there, and so on.
Okay.
All right, so I think that takes you to the end of this one. Go to 7.2. We'll do them in order here. Oh, so this was one of those weird ones that I was not sure how to answer. It had a really long solution.
Oh yeah, I forgot.
I can try to work it out. Let's do 14, and then maybe we'll come back to 13 if there's time at the end.
Okay.
Favorite restaurant offers a total of 13 desserts, of which 9 have ice cream as the main ingredient, 10 have fruit as the main ingredient. Assuming all of them have either ice cream or fruit or both as the main ingredient, how many desserts have both? 10 have a main ingredient, 9 have 10 have fruit as the main ingredient. Assuming all of them either ice cream or fruit or both. I'm gonna just check another question here and see what they come up with before I say anything, because I don't. 5 desserts. Okay, so like there are 9 that have ice cream, 10 that have a main. I mean, 5 comes from just subtracting those 2. That doesn't seem. It seems like it'd be more complicated than that. So that would make your answer 4. Okay, so it doesn't like that. Let me go check this one, see what Chegg has to say. 11. Okay, 11 plus 9. Okay, so this is one of those where it's you're solving an equation. So you're solving this where the total is 13, but you have to take, it's like 9, 10, and then minus a number that's overlapping them equals 13. So it's like 9 plus 10 minus x equals 13. 19 minus x equals 13, which is 6. Okay. Let me just see if I can get something that's more straightforward for this one before we move on. All right, so the first answer here is how many children living in non-urban areas had rickets? So 1,548 were examined, and there were 244 in the study. So the solution here says you just take that total and you subtract the number that were in the urban children. So 1,548 minus 244, like 1,304 children. Nope. Okay. Oh, there's more to it. I'm sorry. That's the number of rural children. The rural children is 1,020 in this. So it subtracts this 1,022 from that number. That doesn't look right either. Sorry, still just not seeing the right answer here. 1,021. It just takes this 1,022 and subtracts this 92. This other solution. I'd really ask, because these should be clearer than this. 930. Submit that answer. And then it does what we just did. Takes that 1,548, subtracts 244. But then it subtracts the number from part A. Okay. So we have 1,548, subtract 244, subtract 930, and you get 374. Okay. Got it. I would ask about those. I don't find them very clear. And maybe an instructor can provide a more direct or so. All right. So let's see. Professor Easy's final examination is 13 true-false questions followed by 2 multiple-choice questions. Each of the multiple-choice questions, you must choose the correct answer from a list of 4. How many possible answers are there? So there's 2 to the 13th possible answers for the multiple choice. 2 to the power of 13, and then you multiply that by, there are 4 answers, and there's 2 of those, so it ends up being a pretty big number, 131,072. Let me know if you want me to start showing work for these.
Sure. For the next one, you can.
Okay. All right. So I'm gonna stop sharing that screen and go back to sharing the one we've been looking at here. So let me grab the snip of it. All right, new share. All right, so you should see this question 7 says your broker has suggested. Is that what you're seeing? Okay, suggested you diversify your investments by splitting your portfolio among mutual funds, bonds, so on and so on. 4 gold mutual funds, 6 municipal bonds, 7 stocks, 3 precious metals, so on. If your portfolio is containing one of each type of investment, so that means you have to choose one of those. So there's 4 possibilities there. 6 of those, 7 of the stocks, and 3 of the precious metals. But you're only choosing one, but that's how many are in each position. We'll see here. So we had to multiply those numbers. We had 4 times 6 times 7 times 3. That's 504. So let me just check that before we move on to part B. All right, that's correct. Okay, so now you have to have 3 mutual funds. Okay, so the problem is like that means there's this mutual fund category. So you have 4 to choose from. So you have 4 choose there, 3 you choose from there, and then 2 you choose from there. But they need 5 municipal bonds. Well, there's 6 that you can choose from to start, then 5, then 4, then 3, and then 2. 1 stock, so there's 7 stocks, and 2 precious metals. So there's 3 precious metals and then 2 precious metals. So to multiply all these together to get our number, there's a lot here, obviously. 4 times 3 times 2. All right, so I get 725,760. Nope, didn't like that. 3 mutual funds. That's 4, 3, 2. 5 mutual bonds. 1, 2, 3, 4, 5. There's 6, 5, 4, 3, 2. 1 stocks. There's 7 stocks and 3 precious metals. 3 times 2. Maybe I didn't put the numbers in the calculator correctly. 4 times 3 times 2. 6, 5, 4, 3, 2. 7, 3, 2. 725,760. Okay, so don't have. I don't know. I don't know what I missed. It could be that there's some ordering here that they're trying to. Yeah, I mean it's NPR. This one has much smaller numbers. So when this is an NCR. They're using combinations. Okay, so the mistake here is that it's 4 choose 3 for the mutual funds. 6 choose 5 because you have 6 mutual funds, and then 7 choose 1 stock, and then you have 3 precious metals and you're choosing 2. So this is not correct. These buckets are wrong here. So 4 choose 3, you got to be able to get that number down. That's a calculator thing again. So that's 4. 6 choose 5. Which is 6. And 7 choose 1. That's 7. And then 3 choose 2. Get these numbers here. 3 choose 2. That's 3. So we got 4 times 6 times 7 times 3. 4 times 6 times 7 times 3. 504. Oh, same number as before. Huh. Okay, so that did work. All right. All right, snipping in the next question. Okay, a nibble consists of 4 bits. Each bit either contains a 0 or a 1. So a bit is this. Each one of these is a bit, and there's 2 possibilities in each. So this is a nibble. And if characters are represented using a code that uses a nibble for each character, how many different characters can be represented? So I think it's asking how many nibbles are there, which is this 2 times 2 times 2 times 2, which is 16. Hopefully that is what it's looking for. And that is what it's looking for. So the rest of this is not useful. It's just this first part here. Mm-hmm. Number 9 is asking about a diner. Number 9 is asking about a diner. All right, the local diner offers a meal combination consisting of an appetizer, a soup, a main course, and a dessert. There's 6 appetizers. 4 soups, 3 main courses, and 6 desserts. But your diet restricts you from choosing between a dessert and an appetizer, so you cannot have both. How many 3-course meals are possible? Okay, so you have, for sure, you're going to have a 6 appetizers, 4, 3 main courses, and 6 desserts. So there's 6 appetizers. So one possibility is you can have all of these, and the other possibility is that you can have all of these. So I think you end up adding them together. You take 6 times 4 times 3, so I can either have those, or I can have 4 times 3 times 6 for that. Is it the same numbers? It is. So it just happens to be the same numbers. I mean, that's because that's a 6 and that's a 6, but that may not always be the case. So that's 72 plus 72, so that's 144. Hopefully that is what it's asking for here. Did not like that. Okay. Oops, I put it in the wrong one. Put it for the next one, which is the some sort of surgical procedure question. Okay, it did work for that. All right, we're on to 10. Let me just check here how many we have left. Okay, so we got 4 here. This is 7 points. Okay, we should be fine, I think, to get through all of these. I feel like I'm rushing a little just because I know you want to get through all of them and make sure.
Yeah, no worries. Thank you.
Yeah. Well, none of this really matters until the exam review, so we do that. Surgical procedure requires 4 steps. The first step has 3 possible outcomes. The second step has 2 possible outcomes, and the remaining 2 can each result in 6 possible outcomes. So I take it to mean, in step 1, step 2, step 3, step 4, 3 times 2 times 6 times 6. That's 216. We'll see if that's accepted here. And it did like that, so that's 216. Multiply those together. All right. Question 12. So we already did question 11. We get question 12 in there. All right, so ice cream shop was founded. It made 36 different flavors. If you had a choice of having a single flavor of ice cream in a cone or a cup or sundae, how many desserts could you have? So there's 36 different flavors, and then there are 1, 2, 3 other ways of having it served. So 3 times 36 is 90, is 108, I guess. 108 different desserts. Okay, that is correct. On to number 13. Ternary digit is either 0, 1, or 2. How many sequences of 5 ternary digits are possible containing a single 1 and a single 2? So there's 5 digits, but it can only have a single 1 and a single 2. So it's like saying, like, well, does the 1 go here and the 2 go here, or does the 2 go here and the 1 go here, or like, so like it's like saying, well, it could be like the 0, 0, 0, 1, 2. That would be okay, but so is 0, 0, 0, 2, 1.
Mm-hmm.
And so on here. So it's like, how do we find the number of positions? So out of these 5 positions, we're choosing 2 of them. We're choosing 2 of them to be in. So, boy, I wish I had a little more understanding of this problem. It's Not seeing a good like explanation here. So there's 5 positions, and the 0 can go in any of them. So there's the 0. There's 5 positions here. Zero could actually go in any of them. So there's 5 ways for that. And then out of the 4 that are remaining, so like after you pick one of these 5 positions, the 1 or the 2 can only go in 4 of the positions. We don't know which one, but we know that there's 4 positions that it could go in. After that, whether we picked a 1 or a 2 to go in there, the other one is forced into only one position. So the shortcut here is that this is a distribution, and it's n times n minus 1 always for this problem. But I don't think that's like really an acceptable thing here. Are you able to see my screen right now? What do you see?
Well, I was looking at the
Okay.
0021.
Because something really weird just happened.
Oh no.
And now there it is. Okay. Okay, so 2020, we're submitting the answer. You can see that now here again. Okay, so that worked. Why is it doing that? It's really weird. Okay. So let me snip the last question in here. Okay. All right, so visual basic names must begin with a letter, uppercase or lowercase, followed by letters, digits, and various special characters. How many different visual basic variable names length up to 3 are possible that consists of letters and digits and ends in a digit? Okay. So it said that they have to start with a letter. There are 26 letters, but if you go upper and lowercase, that gives you 52. It has to end in a digit. So there's 10 digits. The middle one, though, okay, is going to be either a digit or a letter. So there's 52 plus 10 that go here. So we'll try that. We'll see if that works there, where you just multiply those together. 52 times 62 times 10. So that's 32,240. And that did not work. Oh, bro. There's always something to these problems that is clear to the person that made it, or maybe someone who looks at this all the time, but so this solution here I'm looking at actually has the same thing that we just did, 52 times 62 times 10. I'm not sure why I didn't like that. Length of names of length up to 3 are possible. So letters and digits and end in a digit. It has to end in a digit. Okay. Let me just practice another one here and see if I can find the answers. This one has 4. So that's the, okay, 52 times 62 times 62 times 10, and I'm way off. So there's something I'm not by letters, digits, and various special characters. Okay, I don't know how many special characters there are. That's the problem with this one. So this one's gonna be really hard for us to do, and I guess I could figure it out. Okay, so the answer is 2031 640, and if we divide out the 52 and we divide out the 10, That's not going to work. Two numbers never multiply to that. 2031 640 divided by 52 divided by. Okay. I'm going to suggest we just move on to something else, and you can ask your instructor about that. Maybe they
Okay.
will have an answer. Okay. So we got 10 minutes, 10, 12 minutes left. We've got one more section. Only a couple here, though. Okay.
Yeah, I think there's only a few in it.
And this one, these are calculator problems. So P9 comma 2 means permutations. 9 comma 2. So this is 9 minus, or this is 9 factorial over 9 minus 2 factorial, which is 9 factorial over 7 factorial. 9 times 8 times 7 factorial over 7 factorial. Those cancels. It's just 9 times 8. It's 72. But your calculator will just do that. It will just, you just have to get the right sequence of buttons to get that there. Oops, I put it in the wrong one. Okay. And then the next one is 9 comma 8. 9 comma 8. 9p8. So that's 9 factorial over 9 minus 8 factorial, which is 9 factorial over 1 factorial, which is, this is pretty substantial. It's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and then over 1, those cancel. So it's factorial of 9. 362,880. Doesn't like that. Oh, it's C. I'm so sorry. It's 9C8. 9C8. So that's 9 factorial over 9 minus 8 factorial times 8 factorial. So it ends up just being 9 times 8 factorial over 8 factorial, and this is 1 factorial. So those cancel. That's 1. So it ends up being just 9. And that does it there. So the only one that's kind of remaining is that 7-3 question.
Okay, that's okay.
Okay.
I can like email her about it.
Yeah. So you just need to know how many what it means by various special characters. That's what we're missing. That helps us figure out how many there are.
Okay. Okay, I'm fine. I didn't hear it. It's fine.
Okay, excellent. Thanks again for scheduling, and I'll see you next time.
Thank you.
Bye now.
Bye.